Hi, in this video I discuss the basic concepts of thermodynamics. Now, what is meant by thermodynamic system, surroundings, boundary and inverse? We will discuss each concept in practical manner. Now, first of all, what is meant by thermodynamic system? It is a region in space. It is a region in space upon which our study is concentrated. So what is the meaning of this one? For example, we are going to analysis or we are going to study this room. So how many fans are there? How many lights are there? How many desks are there? Now we are going to analysis this room. We have to consider this room as a system. For example, we are going to study this total building. Now we have to consider the total building as a system. So how many rooms are there? How many doors are there? How many toilets are there? We are going to study the total building, and at that time we have to consider the total building as a system. For example, you have to study only this floor. This floor is to be considered as a system. So you understood what is meant by thermodynamic system. It is a region in space. It is a region in space upon which our study is concentrated. So now I am going to study only in this region. This system is considered as thermodynamic system. So why we call it as thermodynamic system? Because in thermodynamics we are interested in what are the changes happening in thermodynamic properties. So what are those properties? Thermodynamic properties are pressure, temperature, enthalpy, entropy, volume, mass, etc. Okay. So this is system, thermodynamic system. And now what is meant by surroundings? See, listen carefully. Very interesting topic. Surroundings. What is meant by surroundings? Everything external to the system is known as surroundings. Simply by the day, everything external to the system is known as surroundings. But up to where I have to consider as surroundings? So let us say this is surroundings. Okay, consider this part as a surroundings. Here, this is all surroundings. But after this board, shall we consider it as a surroundings? No. Why? We will see now. In thermodynamics, we have to consider surroundings external to the system up to where its effects are felt. Okay, everything external to the system up to where its effects are felt. I will explain in practical manner, don't worry. So what is meant by its effects? Now I will explain with a beautiful example. Consider our mechanical thermal lab. We know that in thermal lab, example take ESE engine. Now we are going to study the ESE engine mechanism. Okay. Now which part we have to consider as a system? Now our study is only how the ESE engine is working. Now we have to consider the ESE engine as a system. Now up to where we have to consider as surroundings. Now concentrate here. Now engine starts. We know that combustion process. When combustion occurs, there will be lots of heat generated. When heat generated, the temperature inside the engine is very high compared to the outside. Now here a person standing beside the ESE engine. Okay. Now after some time, when the engine working, after some time this person feel some temperature. So what does this means? When the temperature inside the ESE engine increasing, the heat will be transferred to the surroundings. Yes or no? The heat is transferred to the surroundings so that this person feeling some temperature rise in that body, in his body. For example, this body stands outside the room. Is this person feel any temperature rise in his body? No, because there is some constraint, that is wall. The heat cannot transfer beyond the wall. Yes. So we can say that the heat is transferring up to the walls. Yes. Can I say these are the heat transfer is due to the system? Now can I say this is the effect of the system? Can I say these are the effects of the system? Now we have to say up to where we have to consider as a surroundings, up to where the system effects are felt. Now this is the surroundings. Now we have to consider the total room as surroundings. Hope you understood what is meant by surroundings. Everything external to the system. This is system. Everything external to the system up to where the system effects is felt. Now this part is considered as a surroundings. Hope you understood. Now what is meant by boundary? Boundary. Simply, boundary is a separation layer between system and surroundings. I will draw here. For example, this is system and it is surroundings, and this layer is known as boundary. Okay, this boundary may be fixed, real, imaginary or movable. Keep it in mind, very, very, very important. This boundary may be real, imaginary, fixed or fixed, rigid, okay, or movable, okay. It is this is depends on the type of the system that I will discuss later. Hope you understood. The boundary may be real, imaginary, fixed or movable. Hope you understood. Now, universe. What is meant by universe? The system and surroundings together is known as universe. Okay, the system and surrounding together is known as universe. Here, what is the universe? IC engine, and this total room is considered as a universe. Hope you understood. Next, the thermodynamic system is classified into closed system, open system, and isolated system. Depends on the energy and mass interaction. Okay, this thermodynamic system is classified into closed and open system and isolated system. We will discuss in practical manner. Now, the thermodynamic system is classified into closed system or non-flow system, and second one, open system or flow system, and third one, isolated system. Why we classified into three types of systems? To simplify the analysis. That's it. Now, what is meant by closed system? Now we will see practical meaning of closed system or non-flow system. It is a thermodynamic system in which only energy interaction takes place between system and surroundings. Okay, what I said? Closed system. It is a thermodynamic system in which only energy interaction takes place between system and surroundings, but not mass interaction. There is energy interaction. But no mass interaction. There is no mass interaction takes place between system and surroundings. This type of system is known as closed system. Example, a closed container, it contains some water or any type of fluid. Okay, this is burner. Now we are going to study what are the thermodynamic properties are changing in this container. Now we have to consider this is our system. Okay, now this is system. Now with the help of burner, we are providing some heat to this container. Heat is known as energy. So there is this is system and surroundings. From surroundings, we are providing energy to the system in the form of heat. Now see here, there is energy interaction between system and surroundings. Yes. Now, as the container is closed, there is no mass interaction, between system and surroundings. This type of system is known as closed system or non-flow system. Now, what is meant by open system? This is also a thermodynamic system in which both energy and mass interaction takes place. Hope you understood. Both energy interaction takes place and mass interaction takes place between system and surroundings. Okay, this type of system is known as open system or flow system. This type of thermodynamic system is known as open system or flow system. Example, turbine. Not only turbine, every practical mechanism is almost comes under open system. See here. Now, the steam is coming with a high energy with an enthalpy of H1. Okay. Now, for example, 2000 kilojoule per kg, and leaves with an enthalpy of H2, for example, 1000 kilojoule per kg. Now, steam is entering into the turbine. Here, what is our system? Now we are going to study the turbine. Now, how much energy in the form of work we are getting from the turbine? So, consider turbine as a system. Now see here, steam with high temperature and pressure, with high energy, enthalpy is nothing but energy, is entering from surroundings to the system. And steam having some mass, yes or no? And there is mass interaction between surroundings and system, yes or no? Both energy with an enthalpy of 2000 kilojoule per kg and with some mass from surroundings to system, entering from surrounding to system. Now, can I say there is a both mass and energy interaction? Now, this type of system is known as open or flow system. Hope you understood. Now, last, isolated system. Hope all of you know this. What is in by isolated system? There is no mass interaction, no energy interaction, no mass interaction between system and surroundings. Okay, it is a type of thermodynamic system in which neither mass interaction nor energy interaction takes place between system and surroundings is known as isolated system. Example, a perfectly insulated tea flask. Let us say this is a tea flask. Perfectly insulated tea flask. Okay, here what do you mean by perfectly insulated? Let us say 100% insulation. There is no heat transfer from system to surroundings. Okay, there is no heat transfer from system to surroundings. It is nothing but an energy. So there is no energy interaction from surrounding to system or system to surroundings. And inside we have some tea and it has some mass. Okay, this is closed, perfectly insulated tea flask, and there is no mass flow from surrounding to system or system to surroundings. Now this is an example of isolated system. Or system surroundings and this is universe. And we can take universe is an example of isolated system, because whatever the energy interaction, mass interaction takes place between only system and surroundings, but not beyond the universe. Yes or no? So in this case we can consider universe as an example of isolated system. Okay, hope you understood.